This is Math 8-7, Lesson 99, the Pythagorean Theorem. So the first thing to be able to understand the Pythagorean Theorem, you'll need to know the definition of the hypotenuse and the definition of legs. The Pythagorean Theorem only applies to right triangles, only. The legs of the right triangle are the two sides that come together at a right angle, and the hypotenuse is the angle, or the side exactly opposite the right angle. So this is the hypotenuse. The hypotenuse is always the longest side. This is a leg, and this is a leg. Normally, when you're applying the Pythagorean theorem, they'll call the hypotenuse C, and the legs A and B. It doesn't matter which leg is A and which leg is B. So when we have a right triangle, I'm going to make one that's 4 on the base and 3 on the height. The Pythagorean theorem will tell us that if we were to make a square off of one of the legs, we have this square that I made, this red one, so that could be A, the square there, and you also have a square over purple one over on the four-sided or the four-long leg. So if you count them, this is 9, right? It's 9 little squares, and this one is 16 little squares. If you add them together and compare them to the square that you build off of the hypotenuse, the longest side, they will add together to be the number of squares off the hypotenuse. So 9 and 16 is 25, and this is also 25. It's 5 long, 5, and when I built a square it was 25. So that's always going to happen when you have a right triangle. The square of the two legs, when added together, will equal the square of the hypotenuse, which is the longest side. In their examples, they have a similar situation where they have one side missing, though. In this one, they have 6 centimeters and 8 centimeters. This is definitely the hypotenuse here. It's the longest side. And they want you to draw off of the sides the squares. So if I drew a square here, that was 8 long, and 8 long here, that is 64 centimeters squared. And if I drew a square here, that was 6 by 6, that would be a total of 36 centimeters squared. And I know that the resulting square on the hypotenuse would be 36 plus 64, or 100 square centimeters. That means I can tell the length of the hypotenuse by taking the square root of 100. So in this case, the hypotenuse equals 10 centimeters. This was example 1. In example 2, we have a different triangle with different lengths. And in this case, rather than the hypotenuse being missing, you have a missing leg that they're calling A. This they're calling 12, and the hypotenuse is 13, and the dimensions are in inches. If we draw a square along this leg, that would be 12 by 12, or 144 square inches. If we draw a square here, it would be 13 by 13, or 169 square inches. Now this one is going to be whatever's missing, so this square plus this square will equal this square. So to find the area of this square, we subtract 169 minus 144, or 25 square inches, which means the length of that side, the length of that leg, will be the square root of 25, or 5 inches. In example 3, they give you a triangle, right triangle, and in this case, instead of saying find the third side, they say find the perimeter, which we're going to have to find the third side to find the perimeter. So this will be, if we make a square, that would be 3 by 3, or 9 centimeters squared. This one would be 4 by 4, or 16 centimeters squared. And the hypotenuse, the longest side, will be the sum of those two numbers. So we add 16 and 9 and get 25. Then that means the length of this side is the square root of 25, or 5 centimeters. They didn't ask us for the third side, they asked us for the perimeter. So the perimeter will be 3 plus 4 plus 5 centimeters, which is 12 centimeters. And the last example, example 4, says sketch this right triangle and draw squares on the sides. Then write an equation that shows the relationship between the areas of the squares. This is, they've just named them A, B, and C, like we were talking about before. So that's side A, side B, and the hypotenuse is side C, always opposite the right angle. So we draw squares here, and we don't know the length here. We just call it B, so then the area will be B squared. We don't know this length, A, but the area of that square will be A squared, and we don't know C, but we know that the area of that square will be C squared. So we know that this area, one of the legs, plus the area of the other leg will be the area of the hypotenuse, although I haven't really drawn it that way. So the equation that they would like you to write in this case is that this area, A squared, plus this area, B squared, equals this area, C squared. And that's the Pythagorean theorem.